received our video, so maybe because of this is somehow not here. So Nikhil is collaborating with the dental school on some of the projects, and in case if somebody wants to visit or something, he would be able to help.
Everybody dental school, we can talk about it, we can plan it.
Yeah. So this is Dr. Rashmi from the dental school.
Hi Nikhil, I'm Dr. Rashmi Kumar. The warm greetings from MNR Dental College and Hospital. We are very new to this 3D printing, and some of the questions which we may be asking may be very silly, but we very recently we had organized a national program on 3D printing and their applications in dentistry. With that knowledge, there is some, with that program, we attained some knowledge about applications of 3D printing, the different types of 3D printing which are right now available. As per your email, the two things which was discussed was the mandibular plates and the screws, and the FEA, that is the finito element analysis.
Yeah.
Now, as Jay was talking about, it was about the additive printing through either the plastic or the metal. Now, as Jay was talking about the implants, there has to be made a small distinction between dental implant and a maxillofacial implant. When we are talking specifically about dental implant, we are talking in terms of a tooth. And when we are talking about plate or a reconstruction of a mandible using the DICOM data, that specifically fits into a maxillofacial implant.
Sure, I mean, from our side, since we deal with dental school very often, people like Paulo Coelho is a professor in dentistry, who's quite deeply involved with 3D printing. The way we look at it is the manufacturing of a given part to the highest possible quality and dimension tolerance is our aim. So there are a number of fundamental issues that we identify. So we have certain papers, you can look at some of them, I can send you copies, on the screws used in the dental implants and how the design of them changes based on the quality of the bone that a patient has or the amount of bone that the patient has in the jaw in order to fix the implant inside. The screw design itself is very important, how the pitch of the screw is, how the distance between the threads are, and you really cannot get those kinds of details in a 3D printed part that you can get in a machine part right now. So there is one big problem here that we try to deal with, and the problem is this, that you first have to identify why we go to 3D printing. Okay? If the cast of machine part serving its purpose, then what is the need of going to 3D printing? So after a lot of discussion, what came up is that with a lot of unique problems that patients have in this field, maybe the bone is not enough in certain patients. Maybe there was a tooth first. Maybe there was an implant first, the implant broke off for some reason. And then now we have to do a reconstructive surgery, including a tooth inside. So how do you deal with those kinds of unique situations? So apart from that, the next motivation is that you want the patient to get treated in just one visit. That's the eventual goal for this field. You do not want 2 or 3 visits from the patient. In India, it's not a big deal because cost is low. But every time a patient comes in US, you have to pay $30 or $40, and the treatment cost and the time they just add up. Sometimes patients just don't come back after their first visit. So those are the problems that we identified in our system. And we came up with this goal that somehow 3D printing, if the printer is there in the office of doctor, can provide you that implant in say 2 hours or 3 hours of time. when the patient is waiting outside, and then to do the fixation on the same day. Maybe that's the benefit out from this technique. So, I understand your question. If given the Indian scenario, this is one thing that I would like to ask you, that when you identify any unique scenarios or situations where 3D printing can be used for, because cost is going to be a very big factor. Patient-specific care is really not the focus in India, but the focus is there if you have 3 or 4 different sizes of the same implant. One of them fits the patient, but the cost is so low that the 3D printing cannot compete with it, then there has to be another motivation.
So, to proceed further in terms of materials, when we are talking about 3D printing, we are basically talking about the customized implants or customized processes to an individual. So normally when we are doing a customized implant, you use the DICOM data either from a CT or a CBC. Now, if it can be designed in a with using the CAD file and convert into a .stl file format with the DICOM data, are we specific about materials?
No, we are not. I mean, that only is a design process. There is no material involved at that point.
So once the design is done, what are the available biocompatible materials available using the additive manufacturing device?
So titanium is one material which is available, but the reason for that is not dental or medical implant, but it's because it's used a lot in aerospace field also. So that is driving the development of printers for titanium. And cobalt chrome alloy is the second alloy which is available in good quantity for a number of different types of machines.
So are we talking about the Ti-6 material?
Yeah, Ti-6-4. I don't know if stainless steel T16L is one of the biomaterials in this field, but that's also available.
Have you any time tried with the Ti-6-4 for customization of a root of a tooth?
No, we have not yet tried that.
So can it be taken up for the further research project?
I think it can be taken up. At this point, we have the facility available in our NYU printer, so I'm pretty sure. Some time ago. Yes.
So can it be taken up using this Ti-6-4 in customization of a root of a tooth?
I think it is possible to do.
Because you are talking in terms of the dental implants, customization and personalization. So this from our end, since we have one of the best CBCD units in our campus, we would like to design a CAD file and send it across .stl file to you in replicating a tooth root. Is it possible?
Currently, I'm not working with titanium, but machines are available. So once we decide about pursuing a project, we will have to purchase the titanium powder to print these parts. So I can look into it and we can talk more about it. It's certainly possible on the current facilities we have.
So when you're talking in terms of the mandible, the plate, the mandible plate, which material you are going to use in FEA?
Well, finite element analysis is conducted using mainly elastic properties. Okay, so it doesn't matter what material you use there. You can put any material you want. It could be titanium, it could be steel, it could be just pick any material. Because results will just scale linearly based on the modulus that you take.
From this room, we are slightly little confused.
Okay.
What exactly you would like to do or take up a project to initiate some exchange program from this end to that end?
So, since I come from engineering background, once you make these CAD files, the geometry that you have in mind, you can make in a CAD file very easily. Okay?
Yeah.
But then the CAD file is converted to STL file, and that STL file goes through slicing and then to printing. So what you get out of the printer is not actually what you display in your CAD. It looks very different compared to that. So that process becomes more challenging as the size of the part becomes smaller and smaller. Okay? Bigger size parts you can deal with more easily. The smaller size parts, it's much more difficult to deal with them. So this is what my group is trying to understand, that when you get to the level of dental implants and you design something in the CAD model, what exactly is the output and where do you lose all this information? And how do you design a part in such a way that you eventually get what you're looking for? So it's like, so you will have to provide extra information in a CAD file. It's not just visualization anymore. This CAD file is being printed from a printer which has a limited set of capabilities. So how do you account for the printer resolution? How do you account for the particle size of the particle, which is maybe a 40 micron diameter powder which is being fed to the machine? So those kinds of parameters are important, but designers will not care about them at all. But that's what gives you the quality that eventual part has. Okay. So that's what we are trying to find a solution.
Now
And this is particularly interesting in your field because parts are really small.
Now when we are talking in terms of resolution, what is the resolution capacity right now you have?
The selective laser melting machine that we have is very high end. It's about $1 million each machine. So that gives you around 40 micron feature size, which is the minimum feature.
Using the powder.
Using the powder.
So when we are talking about the size and accuracy, what should be the minimum size or for a 3D printing, which is like suppose now when we are talking about the roots, it is not in a millimeters, it is always in centimeters. So the size of a print, when we are talking in terms of a tooth, it should be in the range of a diameter of more than 15 millimeters and in the length of around 15 or 16 up to 20 millimeters. So is that size sufficient to print?
The size is sufficient. You can send me the design and I can see if there are any features somewhere which are finer than some of the problems we have. So 40 micron is minimum, but that doesn't mean that it defines the problem area. Because anything that you print, it still has about 3 to 5% porosity in the structure. Okay?
See.
So that porosity is not uniformly distributed in the part. You would also have to look for it.
The most important thing in right now in the dental implant is when you have the multi-rooted teeth. That means multi-rooted is more than two roots or three roots, and you are replacing the tooth by using a single implant. So here, what basic problem is with the biomechanics. Now, if a tooth which is having more than two roots or three roots, if it can be replaced by a similar implant which is having three roots, it is very close to the nature. So the reason of asking whether as close as possible to a natural root.
Yeah, material is not a limitation at all in this case.
So from this discussion, I can suggest we can design a CAD file of a patient, and we can send across and see how you can print at 40 resolution.
Okay.
How expensive it will be? Nikhil?
Yes.
How expensive it is to print such thing at 14 micron resolution?
I don't know, but as I said, we don't have the titanium powder yet.
Okay.
So that's something that I would have to look at procuring.
Okay. Dr. Prakash? Nikhil, there is one more question for you.
One more question I have before that.
Please.
So once it is manufactured, what kind of test do you run on it to make sure that this works?
Can you repeat?
What kind of tests do you conduct on a part?
The basic requirement for such material is it has to be government approved material. Since it is being used in human beings, it requires license, whether it can be used in human beings or not. Suppose if it is printed, since in India right now we don't have a law which allows you to print and use it in human beings, it is slightly difficult to apply. But if it is printed outside the country and if it can be brought here, we can do it on an experimental basis. And what we basically look into that is the integration of the material with the natural bone. So the term is the osteointegration.
Yeah.
So before we do it on human beings, normally you require some animal trials to see whether that material is biocompatible or not.
Yeah. So do you have the animal facility on your campus or?
Yes, we have.
Okay. Okay.
At the moment we are not using, but we have a running animal facility with some rabbits and guinea pig.
Okay. We do have here also an animal.
To give you little more information about the same, we have few printing centers in Bombay. They have already used their printers in the replacement of the skull vault. So we have to find what procedure was followed in that case to use that material in those patients. Whether any governing body was regulating in using such material is not very clear.
Okay, but for dental implant, you will still have to look at compressive strength, for example, and shear strength, at least these two factors.
Yeah, that can be, since we have already so many dental implant systems in market, if that can be used as the standard of for the shear strength and other things, if that can be achieved in the printed material, I don't think so it should be a problem.
Okay, but do you have a list of tests and viewing capabilities to do that?
Can you repeat?
The tests that you would have to do in order to compare them, the printed ones versus whatever is out there in the market.
Since there are already, I think what I have spoken regarding the printing of a root of a tooth, it is already being done in some European countries, and it is still in a primitive stage. Since it is a customized, personalized case, and it cannot be used in each and every situation. So there are some specific situations only where you can use such printing as rehabilitated